Right now, the ground beneath your feet is moving at over 1,000 miles per hour. You can't feel it. You've never felt it. But the surface of the Earth, right where you're standing, is spinning through space at roughly 1,270 kilometers per hour at the equator. It has been doing this every single second of every single day since before the first living thing existed on this planet. So what happens if it stops? Not slows down. Not gradually winds down over millions of years. Stops. Suddenly. Completely. The rotation just ends. The answer is one of the most violent, catastrophic chains of events you can imagine. And working through it reveals something remarkable. Just how much of everything we take for granted on this planet depends entirely on that spin. This isn't just a thought experiment. Understanding what Earth's rotation actually does for the atmosphere, the oceans, the magnetic field, the climate, tells you why Earth is the way it is, why it's livable, and what we'd lose if any part of that balance shifted. I've spent years studying planetary science and Earth systems, how the planet's physical properties interact to create the conditions for life. And this particular question, what happens if Earth stops spinning, is one of the best tools I know for understanding how interconnected all of those systems actually are. Pull one thread, and everything starts to unravel. Here's what we're walking through today. First, what happens in the immediate seconds and minutes after the rotation stops, and why almost nothing survives it. Second, what the planet looks like in the months and years that follow, because it gets stranger than you might expect. And third, the long-term reality of a non-rotating Earth, a world so different from ours that it barely resembles the same planet. Let's start at the moment it happens. The Earth stops. The planet itself stops. But you don't. This is the part that gets people. When a spinning object stops suddenly, everything on the surface that isn't bolted to the ground keeps moving. Newton's first law, an object in motion stays in motion. You're moving at 1,000 miles per hour. The ground is no longer moving at all. You, along with every building, every ocean, every layer of atmosphere, every gram of loose material on the planet's surface, all of it continues forward at 1,000 miles per hour. The atmosphere hits first. The entire air column, billions of tons of it, slamming eastward across the surface at supersonic speeds. Winds that make the most powerful hurricane in recorded history look like a gentle breeze. Category 5. Hurricanes have sustained winds around 160 miles per hour. We're talking about winds over 1,000. Winds that would strip vegetation, flatten structures, and scour rock. Every continent simultaneously. The oceans follow. Water, which has been sitting in ocean basins shaped by a rotating planet, now has nothing keeping it in place. The oceans slosh. They surge eastward in walls of water that dwarf anything in human experience. Coastal regions, every coastal region on Earth, are inundated within hours. The flooding isn't measured in meters. It's measured in the wholesale reshaping of coastlines. And you, if you were somehow outside at that moment, you would be flung eastward with everything else, at 1,000 miles per hour, into whatever is in your way. Nothing above the surface survives the first few hours. Nothing. Now, pause there for a second, because I want to ask you something. Before watching this, did you ever think about the fact that you're moving right now? That the ground beneath you is hurtling through space and you've never once felt it? Drop a comment. Does knowing that change how you feel standing still? I'm curious. Okay, the immediate catastrophe has happened. Weeks pass, the planet is unrecognizable, but it's what comes next that most people never think about. Earth without rotation starts to change shape. This sounds strange, but the Earth is not a perfect sphere. It bulges at the equator. The equatorial diameter is about 43 kilometers wider than the polar diameter. That bulge exists because of the spin. The centrifugal effect of rotation pushes material outward at the equator over billions of years, and the planet deformed slightly to accommodate it. Remove the spin, and that bulge no longer has a reason to exist. Gravity slowly pulls it back. The equatorial regions sink. The poles rise slightly. It takes thousands of years, but the planet gradually reshapes itself into a more perfect sphere. And as it does, it triggers earthquakes and volcanic activity on a scale that makes today's geological events look minor. The ocean also reorganizes entirely. Right now, the oceans are distributed the way they are, partly because of how Earth spins. Remove the rotation, and water follows pure gravity. It pools at the poles, the regions closest to the center of the newly spherical Earth. A single enormous ocean forms around both poles, and the equatorial regions, now elevated by comparison, become a continuous band of exposed land circling the entire planet. Think about that. A ring of land around the middle of the Earth, and vast polar oceans covering regions that are currently Antarctica and the Arctic. The map of the world becomes unrecognizable. But here's where it gets even more extreme. And this is the part that most videos stop short of. Without rotation, a day on Earth lasts 1 year. Let that land for a moment. With no spin, the only thing moving is the Earth around the Sun. One side of the planet faces the Sun for 6 months. 6 months of continuous daylight. Temperatures climb, deserts expand. Anything that survived the initial catastrophe faces relentless heat, month after month. Then Earth moves to the other side of its orbit, and that same face turns away from the Sun. 6 months of darkness. 6 months of temperatures plunging toward -100 degrees Celsius or lower. The water that didn't freeze in the polar oceans starts freezing now. Ice sheets spread across what had been scorched desert just months before. A planet with days and nights 6 months long is not a planet that supports the kind of life we know. The temperature swings are too extreme. The atmospheric circulation, which depends on the difference in heating between day and night to drive wind patterns, becomes something completely alien. Massive, slow-moving weather systems that bear no resemblance to anything in Earth's current climate. And then there's the magnetic field. This is the part that concerns scientists most when they think about this scenario in the long run. Earth's magnetic field is generated by the movement of liquid iron in the outer core, a process called the geodynamo. That movement is partly driven and sustained by the planet's rotation. A non-rotating Earth doesn't necessarily lose its magnetic field immediately, but over geological time, without the rotational energy feeding the system, the dynamo weakens. We already saw what happens when a planet loses its magnetic field. We talked about it in the Mars video. The solar wind gets in. It strips the atmosphere particle by particle over millions of years. The planet loses its protection. Radiation reaches the surface, unfiltered. A non-rotating Earth, given enough time, follows the same path Mars followed. The magnetic shield weakens. The atmosphere thins. The surface becomes increasingly irradiated. The conditions for life erode. So here's the full picture. Here is what it actually means for Earth to stop spinning. In the first hours, global supersonic winds and oceanic surges wipe out surface life and reshape coastlines. In the following millennia, the planet physically deforms, oceans migrate to the poles, and a band of equatorial land emerges. In the geological long run, 6-month days and nights create temperature extremes incompatible with complex life. Atmospheric patterns become alien, and the magnetic field slowly weakens, leaving the planet increasingly exposed. It starts with a physical catastrophe and ends with a planet that has slowly become Mars. And here's the thing that makes all of this more than just a hypothetical. Earth's rotation is actually slowing down, gradually. The moon's gravitational pull creates tidal friction that is very slowly transferring rotational energy from Earth into the moon's orbit. 4 billion years ago, a day on Earth was about 6 hours long. Today it's 24. In the far future, billions of years from now, it will be longer still. We are not in any danger. This process is unimaginably slow, and the sun will change long before Earth's rotation becomes a problem. But the fact that it is happening at all is a reminder that none of this is fixed. None of this is permanent. The planet we live on is a dynamic, changing system, and the spin that makes it livable is not guaranteed forever.